Section 4.4 is a real helpful section. It summarizes everything you ought to know about determinants, or maybe not everything, but a lot of what you ought to know. So the determinant of an n by n matrix can be denoted det A, or often just with bars, determinant A. And I'm going to practice using this notation just so you get comfortable with it. A lot of places use exclusively that notation. It's a scalar in the field computed by, if A is a 1 by 1 matrix, it's just that single entry. If A is 2 by 2, it's A11, A22 minus A12 times A21. If n is greater than 2, then what's going to happen is the original definition is the sum along the columns that was -1 to the 1 plus j, a 1j, times the determinant of the a1j minor, right? But then we discovered it doesn't have to be in the first row. You could actually make this an I, that an I, and that an I, and take the determinant along any row. We call that the cofactor expansion along row I. And then we realized that we can also do that cofactor expansion along any column. So the sum I equals 1 to n, -1 I plus j, a ij, times the determinant of the aij minor. Okay, well, why is that? It really comes down to this fact. Remember, the determinant of A transpose is exactly equal to the determinant of A. So if you want to think about going along a column, we'll just take the transpose and then it's some row, and then you can sort of go back and forth between the rows and the columns. Just pick the easiest one. Here is an example that I'll just work through real fast. So let's imagine, just for funsies, I wanted to do the cofactor expansion along this column. Okay, so I'd say, okay, well, this entry is the first row and third column times 3, that entry, times the cofactor of that. That's going to be the determinant of the matrix 5, 0, 8, 9, 10, -8, 0, -1, 0, 1, -1, right? Plus -1 to the 2 plus 3, that's that entry, second row, third column, times 0 times the determinant, but that's just 0, plus -1 to the 3 plus 3, times 2 times the cofactor with respect to that 2, which is 1, 2, 14, 5, 0, 8, 0, 1, -1. And notice you could get to that -1 to the 6th by going plus, minus, plus, minus, plus, right? Because it's even and odd. And then the last thing is, of course, -1, fourth row, third column, times 0. So that disappears. So this has to be a recursive sort of process here. Well, this is 1, so we've really got 3 times the determinant of this thing right here. Well, let's just take the cofactor expansion along the top row. So what is that? That's 5 times the determinant of the cofactor expansion, 10, -1, 1, -1, -8, -1, minus 0 times the cofactor expansion relative to that, which is just 0 times anything is 0, plus 8 times the cofactor expansion of 8, 9, 10, 0, 1, plus 0, plus 2 times the cofactor expansion. Let's just go ahead and go along the bottom row here. So this is plus, minus, plus. So 0 minus 1 times the cofactor expansion relative to that. That's 1, 5, 14, 8, plus -1 times the determinant of 1, 2, 5, 0, right? Okay, so then what do you have? You have 3 times the determinant here is negative 10 plus 8. So that's 5 times negative 2 plus 8 times 9 minus 0. Let's see, so here we have, let's see, negative what? That's negative 8 plus 70, so I guess that's 62. And then minus, what's this here? Sorry, that's negative 62 in there. And then here we get 0 minus 10. Okay, so what is that? That's 3 times 72 minus 10, that's 62, plus 2 times, let's see, 62 plus 10 is 72. All right, so what is that? That's 186 plus 144 equals 330. So there's an example of using cofactor expansions along columns and rows.